Good morning and welcome to the review of radicals. In this video we are going to be able to simplify a radical with or without variables, simplify cube roots with or without variables, and add, subtract, or multiply these radicals. To start out, we are going to look at examples of simplifying radicals where one of them is a square root and the other is a cube root. So on the left hand side I have a square root of 980 x to the third, y to the fourth, z to the ninth. To start out, I am going to simplify each, or I'm going to separate each term to be simplified. So I'll start off with the square root of 980, the square root of x to the third, square root of y to the fourth, and the square root of z to the ninth. When I start off with my numbers, for example, the square root of 980, I am looking for the largest perfect square that can be multiplied or divided into that number. So for this example, I see that I'm going to use the square root of 196 and the square root of 5. Now I have variables here with exponents. When you have a square root, you are looking at the index to determine what you're going to divide the exponent by. So here there is no index, which means that we assume that it's 2, and we're going to divide each of the exponents by 2. So when I look at 3 divided by 2, I get 1.5. What I'm going to do is I'm going to factor out my 1x, and then I'm going to leave 1 underneath. This is going to say where if I was to go back and square these, I would get my x to the third. With the square root of y to the fourth, 4 divided by 2 is 2. I just have y squared. And with square root of z to the ninth, I'm going to say z to the fourth with 1z left over. Now I can simplify the square root of 196 to 13, square root of 5, x, square root of x, y squared, z to the fourth, square root of z. Now, to arrive at my final answer, all I'm going to do is take all the terms on the outside of the radical, 13x, y squared, and y to the fourth, z to the fourth, I'm sorry, and we're just going to write them on the outside, 13x, y squared, z to the fourth. And then with whatever underneath the radical, so my 5xz will just stay underneath the radical. So that's how we simplify a square root. When we want to simplify a cube root, it is very similar, except the only difference is we are going to look for the largest cube root, and we divide those exponents by 3. So to start off, I am going to split up each and individual term. Cube root of 448, cube root of x to the sixth, cube root of y to the ninth, and the cube root of z to the eighth. So when I look at the cube root of 448, I begin looking for the largest perfect cube. The largest perfect cube that goes into 448 is 64. So I'm going to have the cube root of 64 times the cube root of 7. Now, as we said with the square roots, we divide those exponents by 2 based off the index. But at a cube root, my index is now a 3, so I'm going to divide those exponents by 3. So 6 divided by 3 will give me 2. 9 divided by 3 is 3. And 8 divided by 3 gives me 2 with 2 remaining. So I'm going to write z squared, cubed root of z squared. So again, the same concept. Simplify that cube root of 64. I'm going to have 4 cube root of 7, x squared, y to the third, z squared, cube root of z squared. And my final step is to take everything on the outside of the radicals and combine them. So 4x squared, y to the third, z squared, cube root of 7z squared. So that's how you simplify the square roots and the cube roots. I'm going to look at some old SOL examples where I see what is the square root of 108 written in simplest form. So I start looking for my largest perfect square. So I will write square root of 108, and I'm looking for my two terms that are going to multiply together that give me the 108, and I see 36 and 3. I simplify the square root of 36 to 6 and keep the square root of 3. Therefore, my answer choice is C. If you were to take a different approach on this, let's say that you take the square root of 108 and you split it into the square root of 54 and the square root of 2. Now, I know I can keep simplifying the square root of 54, which will go into the square root of, no, not the square root of 9. So we are going to use the square root of 9 and the square root of 6 here, and you'll see why in a minute. I can simplify the square root of 9 down to 3, and I have the square root of 6 and the square root of 2 left over, so I'm going to multiply them together to get 12. I can simplify the square root of 12 down to 4 and 3, so I'm going to have 3 square root of 4 square root of 3. Square root of 4 simplifies to 2. And then the square root of 3 stays. 3 times 2 is 6 square root of 3. You do arrive at the same answer, but in the directions it does say simplest radical form, so you need to make sure that you simplify it all the way down. The expression 5 square root of 7 is the simplest radical form. Now, there are two ways you can do this. You can go ahead and simplify every single one of these, but we know, based off the work we've done, we're looking at the square root of two numbers that multiply together to give me. So what if I took the square of 5? If I take 5 squared, I get 25. So I know that I'm right now looking at, if I was working backwards, the square root of 25 and the square root of 7. So all I'm going to have to do is multiply 25 times 7 to get the square root of 175, which would be my answer choice C. Now we are going to go into adding and subtracting radicals. And in this example, it gives the answers as decimals, but I'm not going to show you the decimal way. I'm going to show you the radical way. When you simplify radicals, when you add, subtract, you have to make sure the number underneath the radical is the exact same. I'm going to throw away that last question because there was no largest factors that would work. So I'm going to come up with a different question where I'm going to see 2 square root of 147 plus 3 square root of 300. Just like we've been doing in our other problems, we're going to simplify the numbers down first. So I'm going to have 2, and there's 2 square roots that work out into 147 plus 3, and then the 2 square roots that work out into 300. For the square root of 147, I'm going to use 49 and 3. And for the square root of 300, I'm going to use 103. So I'm going to start simplifying these down. 2 times 7 square root of 3 plus 3 times 10 square root of 3. 2 times 7 will be 14 square root of 3 plus 3 times 10 is 30 square root of 3. Now, for us, in order for us to actually add or subtract these, the numbers underneath the radical have to be the exact same. So I see the square root of 3 and the square root of 3, which means that I can add. All I'm going to take is 14 plus 30 to get 44 square root of 3. And that's my final answer. Now, there is a difference when we start multiplying radicals, because I do not need a common number underneath the radical. I'm just going to multiply the outside and then multiply the inside. So to start off, 5 times 4 will give me negative 20. Square root of 18 times 20, which will give me 360. I'm going to simplify inside the radical. So the negative 20 will stay, and I'm going to split this up into 36 and 10. Negative 20 times 6 square root of 10, and negative 120 square root of 10. There's our simplest radical form for this problem. Looking at another example, negative 9 square root of 3 times negative 4 square root of 12. I'm going to multiply the negative 9 times the negative 4 to get 36. And then I'm going to multiply the 3 times 12, which will give me 36. I can simplify inside the radical to become 6. And 36 times 6, 216. And there would be my simplest form. That is all we have for the radicals. Remember, when you are simplifying them, look for the largest perfect square or perfect cube. Divide those exponents by what your index says, so 2 or 3. When you add or subtract radicals, they have to have the same number underneath the radical. And for multiply the numbers together and then simplify from there. Thank you.